In this video, we're going to focus on how to graph exponential and logarithmic equations. So let's begin with this one. So let's say that y is equal to 2 raised to the x plus 3 minus 4. So let's make our x white. Well, that was a terrible line. Okay, there we go. Let's make our graph. Now the first thing you want to do is plot the horizontal asymptote. Exponential functions, when you have x in the exponent, this is the horizontal asymptote. This number to the side, -4. So 1, 2, 3, 4. It's going to be right here. That's where the graph usually starts from. Now the next thing you want to do is find 2 points. Set the exponent equal to two numbers, 0 and 1, and solve for x. If you solve for x, you're going to get -3, and 1 minus 3 is -2. Now if you plug in -3 into this equation, -3 plus 3 is 0. 2 raised to the 0 power is 1. Basically anything raised to the 0 power is 1. And 1 minus 4 is -3. I believe I did my math correctly. Now let's say if we plug in -2 for x. -2 plus 3 is 1. 2 raised to the 1 power is 2. 2 minus 4 is -2. Now your next step is you want to plot those 2 points. So this is just a rough sketch. I know my graph is not perfect, but we have a point at -3, -3, which is somewhere over here, and -2, -2, which is in this area. So now what you want to do is, to graph it, start from the horizontal asymptote and follow the 2 points. And that's a rough sketch of your graph. You can add more points if you want to, but you just need 2 points to get the right direction. So let me give you another example. Let's say that we have this function, y is equal to 3 raised to the 2 minus x plus 1. So first, plot the horizontal asymptote, which is at +1. So it's 1, 2, 3, 4. So it's over here. Next, set the exponent equal to 0 and 1, and then solve for x, and then make a table. So if we add x to both sides, or if we add x to the first equation, we get 2. For the other one, 2 minus 1 is 1, so x is 1. If you solve for x, you should get those 2 numbers. Now, if we plug in 2 for x, 2 minus 2 is 0, 3 to the 0 power is 1, 1 plus 1 is 2. And if we plug in 1 for x, 2 minus 1 is 1, 3 to the first power is 3, 3 plus 1 is 4. And then plot those 2 points. So the first one is 2, 2. That is not 2, 2. It should be over here. The next one is 1, 4, which is around here. So notice that the graph has to start from this side, from the asymptote, and it follows those 2 points. And there you have it. So now let's try another problem just like that. Let's say if y is equal to 3 minus 2 and then x plus 1. So start with the horizontal asymptote, which is at 3. Let's plot that first. Take the exponent, set it equal to 0 and 1. And then solve for x. So x is equal to -1 and 0. Then plug those numbers back in. If we plug in -1 for x, -1 plus 1 is 0. 2 to the 0 power is 1. 3 minus 1 is 2. Now, if we plug in 0 for x, 0 plus 1 is 1. 2 to the first power is 2. 3 minus 2 is 1. And so now let's plot those points. So the first one is at -1, 2, which is right around here. The next one is 0, 1. So if we start from the asymptote, notice that the graph is going this way. and you can add more points to it. So that's how you can get a rough sketch for exponential functions. But now let's go into logarithmic functions. So let's say if we want to graph y equals log base 2 x minus 1 plus 3. Now, you want to take the inside part of log, which is right here, and set that equal to three things. You want to set it equal to 0. This will give you the vertical asymptote. And then you want to set it equal to 1. And you want to set it equal to whatever this number is, the base, 2. These are the 2 points you're going to plot. And this one is your vertical asymptote. So solve for x in each condition or each situation. For the first one, x is 1. That's the vertical asymptote. And then for the other two, the second one, x is 0. Not 0. X is 2. 2 minus 1 is 1. And for this one, x is 3. 3 minus 1 is 2. Or if you add 1 to both sides, you can get 2 and 3. Now, keep in mind, logarithmic functions, they have vertical asymptotes. The exponential functions have horizontal asymptotes. The first thing you want to do is plot the vertical asymptote, which in this case is at x equals 1, which is around here. Now the next thing you want to do is plot the points, but we got to find the points first. So let's plug in 2 for x. 2 minus 1 is 1. Log 1, regardless of what the base is 0. And then 0 plus 3 is 3. Now let's say if we plug in 3 for x. 3 minus 1 is 2. Log base 2 of 2, because the 2's are the same, they cancel, it's just 1. Then 1 plus 3 is 4. If you always do it this way, you're going to make graphing logs a lot more easier. Or a lot easier, I should say. But now let's plot these points. So when x is 2, y is 3. And when x is 3, y is 4. So that's over here. So if we start from the asymptote and then follow the points, the graph is going to look something like that. Now, let's try this one. Log base 3, 4 minus x minus 2. So let's plot the vertical asymptote first. Well, we got to find it though. Let's set the inside part. 4 minus x equal to 0, 1, and the base, which is in this case 3. And let's make the table. So for this one, x is 4, which is the vertical asymptote. 4 minus 3 is 1, so x is 3, which that's a terrible 3. We can put it here. And then 4 minus 1 is 3, so this is x is 1. And let's plug those points in. So we plug in 3 here. 4 minus 3 is 1. Log of 1 is always 0. And then 0 minus 2, we get negative 2. Now if we plug in 1 for x, 4 minus 1 is 3. Log base 3 of 3, they're the same, that's 1. 1 minus 2 is negative 1. Okay, so now we can plot the vertical asymptote, which is at 4. 1, 2, 3, 4. And the y values are negative, so we'll just plot those points. The first one is at 3, negative 2, which is around here. The next one is at 1, negative 1, which is right here. So the graph starts here, then it follows those 2 points. Now let's say if you want to get another point, what should you choose? If you wish to get extra points to your graph, here's what you need to do. 3 to the 0 power is 1. 3 to the first power is 2. See how those numbers, 3 to the 0 power is 1. 3 to the first power is 3. That's how we get those numbers. 3 to the second power is 9. 3 to the third power is 27. If you want extra points, follow that trend. It's based on the base that you choose. So if we solve for x for this equation, it has to be negative 5. 4 minus negative 5 is 9. We're not going to worry about this point, but that's just an extra point if you want it. Now let's say if we plug in negative 5 here. 4 minus negative 5 is 9. Log base 3 of 9 is 3 to the what power is 9? 3 to the second power is 9. So log base 3 of 9 is 2. And then 2 minus 2 is 0. So if you choose these points, if you choose these numbers, you're going to get nice whole integers. You're going to avoid decimal values. So if we wish to plot the other point, it's going to be at negative 5, 0, which is somewhere over here. So our graph wasn't perfect, but let's see if we can draw it more accurately. So it should be more like that. So if you get a third point, you just make your graph look better. Let's try one more example in which we'll actually get like another point or two. So let's say if y is equal to 3 minus log base 2 of x plus 1. So let's set x plus 1 equal to 0 for the vertical asymptote, equal to 1, 2 to the 0 is 1, equal to 2, 2 to the 1 is 2, equal to 4, 2 squared is 4, equal to 8, 2 to the third is 8, and if we want 16, 32, 64, you get the pattern. You just keep going. Alright, so for the first one, x is negative 1. We just got to subtract each number by 1. And that's the vertical asymptote. But let's make our table first. So for the second point, 1 minus 1 is 0. The next one is 1, and then 3, and then 5. So if we plug in 0 in for x, 0 plus 1 is 1. Log base 2 of 1, log of 1 is always 0. So 3 minus 0 is just 3. If we plug in 1 for x, 1 plus 1 is 2. Log base 2 of 2, they're the same, they cancel as 1. 3 minus 1 is 2. Now if we plug in 3 for x, let me write this example out so you can see what's going on. 3 plus 1 is 4. Log base 2 of 4. 2 to the what power is 4? 2 squared is 4. So log base 2 of 4 is 2. Another way you can figure this out, if you want to find log base 2 of 4, you can type in log 4 divided by log 2 in your calculator, and you should get 2. So 3 minus 2 we said is 1. The last one we're going to plug in is 5. So 3 minus log base 2, actually, well, not 5. This is supposed to be 7. If I subtract 1 by both sides, that's 7. Missed that. Alright, so we got to plug in 7. 7 plus 1 is 8. So 2 to the what power is 8? If you type in log 8 over log 2, you're going to get 3, because 2 to the third power is 8. So 3 minus 3, we get 0. Okay, so first let's plug in the vertical asymptote, which is at negative 1. Let's draw that on the graph first. Now let's plot our points. So the first point we have is 0, 3, which is right there, and then 1, 2, and then 3, 1, and then 7, 0. So the graph is going to start from the asymptote, and then, well, I missed that point. It's going to follow these points. And so that's how the graph looks like. So you can get as many points as you want, as long as you follow the trend. This is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And then just do what we did. So that is it for this video. Thanks for watching, and have a great day.